All right, let's talk about one of the most powerful tools out there for anyone building software today, Google Kubernetes Engine, or as you'll always hear it, GKE. We're going to look at how it takes the absolute chaos of running modern apps and, well, tames it. So think about this for a second. You've built an amazing app. The code is brilliant. But now what? Seriously, how do you get it out to the world? Handle that crazy traffic spike when you suddenly get popular? And maybe most importantly, fix it when it breaks at 3 a.m., all without hiring a giant team of engineers just to keep the lights on. That's the real world problem, right? And right there, that is exactly the problem GKE was designed from the ground up to solve. You can think of it as the ultimate conductor for your application's orchestra. It manages the code, the servers, all the moving parts, so they actually work together in harmony. Okay, so here's how we're going to break this down. First, we'll cover why GK even exists. Then we'll walk through getting your first app running. After that, we'll talk about updates and making your app reachable. Then the fun part, handling wild success with auto-scaling. We'll wrap up with monitoring and health checks. And finally, the big decision, autopilot versus standard mode. Let's jump in. First things first, why do we even need something like GKE? Well, it really all boils down to one thing. Managing applications gets incredibly complicated, especially when they start to grow. Probably the best way to get your head around GKE is with this analogy. Imagine GKE is a brand new, fully managed apartment complex. You, the developer, are the tenant. Your only job is to worry about what's inside your apartment, your app, your code, your cool features. You don't have to think for 1 second about the building's plumbing, the electricity, or the foundation. GKE is the building management that handles all of that messy infrastructure stuff for you. All right, section 2. Let's run our first app. How do we actually move you into one of these apartments? How do you get your code from your machine into this GKE complex? So the most basic fundamental thing in this world is called a pod. And sticking with our analogy, the pod is literally your apartment. It's the smallest thing you can work with, and its one job is to hold your application. Now, your app's code and all its dependencies get bundled up into a neat little package called a container. The pod is what holds that container, giving it its own private space and its own unique address inside the complex. But you don't just manage these apartments one by one. That would be crazy. Instead, you talk to the building manager, and in GKE, that's called a deployment. A deployment is basically a blueprint. You write it up, and you tell it, hey, listen, I need you to make sure there are always 3 identical apartments running my app, no matter what. And that's the deployment's job. If one of those pods crashes, poof, it's gone. The deployment sees it and instantly spins up a new one to take its place. It's self-healing. So how do you actually do this? You'd be surprised. It's really a 2-step dance. First, you use a tool called gcloud to create your GKE cluster. That's like building the entire apartment complex. Then, you use another tool, kubectl, which is kind of the universal remote for all things Kubernetes, to hand over your deployment blueprint. So first, you build the complex, and then you tell the manager how to fill the apartments. Simple as. Okay, awesome. Your app is running in its pods, but we all know a developer's job is never really done, right? So section 3 is all about updates and services. How do you update your app with 0 downtime? And, how do people actually find it? I mean, this is the classic nightmare scenario. You have a critical bug fix or a brand new feature you're dying to release. How do you roll it out without taking the whole site down and putting up one of those "sorry, we're closed for maintenance" signs? Users expect things to just work 24/7. And this is where the magic of GKE really shines. The answer is a single, simple command, kubectl set image. You run that, and you're basically telling the deployment, hey, building manager, I've got a new design for the apartments, start using this new version. And GKE kicks off what's called a rolling update. It doesn't just bulldoze everything. Instead, it gracefully brings up a new pod with the updated code, waits for it to be healthy, and only then does it take down an old one. It does this little dance, one by one, until everything is updated. For your users, it's completely seamless, 0 downtime. Okay, so the app's running, it's updated, but how does the outside world talk to it? I mean, pods get replaced, their internal addresses are constantly changing. We need a stable front door, and that's exactly what a service is. Think of it like the front desk and the permanent mailing address for your building. The service gets a single, stable IP address that never changes. All your user traffic hits the service first, and it acts like a smart receptionist, directing that traffic to whichever of your pods are healthy and ready to go. All right, so your app is live, it's reachable, it's easily updated. And then it gets popular, like really popular. This brings us to a really good problem to have, which is what Section 4 is all about: handling success with autoscaling. We're going to see how GK can take you from a handful of users to millions, basically without you lifting a finger. The first tool we have for this is the Horizontal Pod Autoscaler, or HPA. Its job is to watch the load on your application, usually your CPU usage. When traffic starts to spike and your pods are working hard, the HPA just adds more pods. It's exactly like a manager at a busy grocery store who sees long lines and immediately opens up more checkout lanes. It keeps everything flowing smoothly. But what happens when you've opened all the checkout lanes you have space for? What if the HPA wants to add more pods, but your apartment complex is completely full? There's just no more room. Well, that's where the cluster autoscaler steps in. It's watching for that exact problem. And when it sees you're out of space, it automatically adds more physical machines, more servers, which we call nodes, to your cluster. It's like the building owner deciding to add a whole new wing to the apartment complex on the fly because demand is through the roof. So the huge takeaway here is that you use these two together. The HPA scales your application, the pods, your checkout lanes, and the cluster autoscaler scales your infrastructure, the nodes, the supermarket building. When you combine them, you get this beautiful, fully automated system that just expands to meet any demand, and then, just as importantly, shrinks back down when things get quiet, which saves you a ton of money. Okay, now let's get real for a minute. Even with all this amazing automation, things can and will go wrong. That brings us to Section 5, monitoring and staying healthy. How do you figure out what's broken, and how do you fix it fast? So let's say your users are complaining about errors, or you see a pod that's just restarting over and over again. What's the very first thing a developer does? Yep, check the logs. Now, the old way was this painful process of SSHing into a bunch of different servers, trying to find the right file. With GKE, it's all centralized. Cloud operations for GKE just sucks in all the logs from every single container and puts them in one place. You can search, filter, and pinpoint the exact error from the exact container that's misbehaving, all from one dashboard. But just checking logs when things are on fire is reactive. GKE also lets you be proactive with things called probes. These are just little health checks you set up for your pods. A liveness probe is constantly asking a simple question. Hey, are you still running or are you frozen? If it fails that check, GKE just automatically restarts the pod for you. Then there's the readiness probe. It asks a different question. Okay, I know you're running, but are you actually ready to take traffic? This is super important for apps that need a little time to warm up. If that probe isn't passing, GKE will wait and won't send any users its way until it's good and ready. We have covered a ton of ground. Now for the last piece of the puzzle. This is a big decision you have to make right at the very beginning. Section 6, Autopilot versus Standard Mode. So, when you create a GKE cluster, you've got two main flavors to choose from. Standard mode gives you maximum control. You are the hands-on building manager. You get to pick the size and type of your machines, your nodes, but you also pay for them, even if your apartments are empty. Then you have Autopilot mode. This is all about maximum convenience. Google manages all the nodes for you. You literally don't even think about them. You just say, I need to run these pods, and the infrastructure magically appears to support them. And the billing model reflects that. You don't pay for the machines, you only pay for the pods you actually use. It's the ultimate pay-for-what-you-use setup. So let's just pull this all together. From deploying that first apartment to automatically adding new wings to your complex when you get famous, what's the big idea here? The whole point of GKE is to automate the incredibly operational burden of running software. It's designed to let you stop worrying about the plumbing and the foundation so you can focus all your energy on what actually matters, building amazing features for your users. And that really leaves us with one final thought. We've gone through the why and the how of Google Kubernetes Engine. We've seen how it takes all this complexity and just automates it away. So the question isn't really about the technology anymore, it's about what's possible. What will you build when that whole burden of managing infrastructure is just gone?